Okay, so chapter 5 is something that in a typical class, not saying you're typical or atypical, but in a typical class, this is something students like. This tends to be, knock on wood, the best test of the 5. And I think it's because in your algebra classes you've had in high school, you've seen this a whole lot. Okay, but don't let that stop you. Okay, I just say that to give you a little bit of confidence. Don't let that stop you from asking whatever questions you need to ask, okay? Because that's why we're here, we're together. Otherwise, we wouldn't need to do this. So chapter 5 is all about factoring. In the last section, we're going to use factoring for solving a new type of equation. And so we will build up to that. Now remember, excuse me, on the first day of class, I said there's a difference between an equation and an expression. Equations have an equal sign and we solve them. Expressions don't have equal signs and we do various things to manipulate them, like collect like terms and do things like that. What we're going to do here on these expressions, because notice nothing on these pages that I've given you has as an equal sign, is we are going to choose to factor them. Sometimes when you're doing stuff in algebra, it's handy to factor. Sometimes it's handy to unfactor or distribute or multiply, which is just what the reverse of factoring is. So we're going to practice this process. So what we're going to do is we are going to factor each of the things on these pages. And we're going to do two things. We're going to factor the greatest common factor out of expressions. And then when appropriate, we're going to talk about the first method of factoring, which is grouping, which is based on factoring out the common factor. So what do I mean by factor out the common factor? We'll look at example 1. I've got 9x plus 18. So when I look at this, I've got two terms. I've got the term 9x. I've got the term 18. What factor, excuse me, do both 9x and 18 share? What do they have in common? 9. They both have 9. Okay. Now you might say 3. Could I do 3? I'll talk about that in just a minute. But we are always going to be looking for the greatest common factor. So the biggest thing that they share. So we're going to factor out the 9. Now, all factoring is like undistributing, okay, if you want to think of it like that. And so my thought process goes like this. I'm factoring that 9 out. And then there's one of two ways that you can see this. That's pretty common. What I like to do is I like to say, okay, 9x divided by 9 leaves me what? X. And then 18 divided by 9 leaves me 2. And there we go. I've undistributed. Another thing you could ask yourself, if you don't like that division question, is you could say, what first thing here times 9 gives me 9x, and that's x, of course. And then what second thing here times 9 gives me 18, and that's 2. Now, some of you, I'm sure more than one, because I see this on the test sometime. So some of you might have said, hey, Perkster, I can see 3. 3 is in common to 9 and 18, and you're absolutely 100% correct. And sometimes, depending on the numbers, it's handy to whittle them down a little bit. Okay, so if you said 3, that's fine. So then 9x divided by 3 leaves 3x. 18 divided by 3 leaves 6. But then here's the thing. Don't rush on to the next problem. Always look and say, does what I have left still have something in common? And now that the numbers are a little smaller, maybe you'll say, oh, there's another 3 in common. Okay, so then what you would do, because we should always end up with the same answer no matter what route we've taken to get there, this is the first 3, I'm just going to put it right here, times, then I take the second 3 out. Now 3x divided by this 3 leaves x, 6 divided by 3 leaves the 2, and then last but not least, the 3 times 3, both of those 3's that I factored out, when I multiply them, make 9. So you see, I get the same thing. The nice thing about factoring is if you want to check your answer, make sure things went well for you, you can just redistribute real quick. 9 times x is 9x, 9 times 2 is 18. Boom, we're done with that problem. So that's as much explaining as I can do of factoring. So as we're going through, if there's something I've not been clear about, let's bring it up. Let's get it out in the open so that you are experts at this. So in the meantime, do exercise 1 right there to the right. I'm going to give you 30 seconds. Factor out the greatest common factor. Now, I'm not going to do every problem more than once, so just know if you took out something smaller than the greatest factor, just like I demonstrated on the previous problem, you can get to the final answer, okay? That should not be a big deal. You just might take 1 or 2 or 3 extra steps. What is the greatest thing both 8x and 12 have in common? 4, yes, thank you very much. So I'm going to factor out a 4. And when I factor out a 4 here, 8x divided by 4 leaves me 2x. And then negative 12 divided by 4 leaves me negative 3. Just do a quick check. Do 2x and 3, do those have anything in common anymore? No, I took out the greatest thing because I was told that. So fantastic, we're done with that problem in one step. Again, I don't want to beat this dead horse too much, but if you took out a 2 first time, that's great. Then you would notice that the 2 terms you have left still have a 2 in common. And you just go through the process again. All right, try exercise 2 right below. 6y plus 24. Factor out the greatest common factor. All right, what's the biggest thing in common between 6y and 24? 6, fantastic. So this, I'm going to factor out that 6. And then what's left? Well, 6y divided by 6, or when you factor that 6 out, leaves just y. Then 24, when I factor that 6 out, leaves me plus 4. Anybody got a question, a comment, or a concern before I had to do the next one? Okay, the only difference on the next one versus the ones we've already done is now there's 3 terms, but your process is no different. So do exercise 3, please. All right, between 28, 21, and 35, what's the greatest common factor? Yep, each of them have a 7 that I can factor out. Great. So 28, when I factor out the 7, leaves me what? Perfect. Thank you for that x squared. And 21x divided by 7 leaves me what? Perfection. Wonderful. And then what's my last term? 35 divided by 7 is 5. Excellent. All right, I'm just going to count on you to stop me when you need something clarified. Otherwise, I'm just going to keep going through. Okay, I'm not in a rush. We have so much time. It's silly today. So any questions you ask will not hold us up at all. Do exercise 4. All right, I have a purpose with this problem, as I do with several of them as we go through. What's the common factor between these 3 terms? 5, sure. Okay, when I factor the 5 out of the first term, what's left over? Yep, excellent job. When I factor the 5 out of the middle term, I have what? Now here's my purpose with this problem. Do not get in a rush and forget this last thing. How many terms did I start with? 3. How many terms should I have in the parentheses? 3. So when I factor 5 out of this last term, what is left over? 1. Do not forget the 1. That is the most common factoring out the common factor mistake students will make. You get in a rush, you say, oh, I factor the 5 out, and you think to yourself, there's nothing left over. but that's not true. There is something left over, the placeholder, that 1, because when I remultiply, I should have 3 terms, and I should have a 5 in the last position. If you leave off that 1, you now only have 2 terms, and when you remultiply, you won't have the 5 anymore. Okay, so don't forget that 1. That was the point to that problem, is to just bring up that issue. All right, next problem, right next door. I've got 5x to the 4th plus 4x squared. Now notice in this one, the coefficients 5 and 4, they do not have anything in common, but I do have some variables in common, and that's the purpose to this problem. So the first term, how many x's does the first term have? How many x's does the second term have? Okay, 4 and then 2. So if I'm going to take an equal number of x's from each, how many are they each going to donate? 2. So I'm going to take out x squared. So in general, if you're looking for just a nice little quick rule to follow, you always take out the lowest power. Notice on all the other problems, there has not been a variable in common to every term. Okay, so that's why I haven't brought it up until this point. And so now here we go. When I have 5x to the 4th, I've factored out 2 of the x's. What's left? Yes, thank you very much. 5x to the 2nd. Remember, what is our, just in case you're checking as we go, what is our property that we reviewed a couple sections ago? When I remultiply, when I multiply the x squared times the x squared, what do I do with the exponents? You add them. So 2 plus 2 should give me 4, and indeed it does. The next term, plus, when I factor out the 2 x's there, what's left from that term? Okay, I'm going to disagree on one thing. I'm just going to put the 4, because if I put the x there, I've got a pencil here somewhere. If I put the x there, x squared times x, how many x's is that going to be now? That's going to be 3, so I've changed the problem. Okay, so when I started out here with 2 x's, I factored both x's out, so I no longer need an x in this term. Okay, so great thing to mention. I'm glad you did. Okay, so that's just something to mop up on the next problem. Are we good? All right. All right, well then do the same thing. Exercise 5, right below it. Factor out the common factor to that, please. All right, what's in common to those 2 terms on this problem? Yeah, y to the 3rd. There's 3 y's in common. Remember I told you the lowest power. I've got 6 y's in the first term. I've got 3 y's in the second term. So the lowest power is 3. The 7 and the 5, the coefficients, they have nothing in common. So here we go. I started with 7y to the 6th. I factored out 3 of the y's. So what's left? Perfect. 7y to the 3rd. Excellent. Minus, I started with 5y to the 3rd. I factored the 3 y's out. What's left from the second term? 5. Just the 5. Excellent. Great work. Okay, again, if you got a question, you're not a holdup. We're still going to get out early today. Don't you worry. Okay, so you ask your questions, whatever you have. I want you to, while you're enduring the hurricane, I want you to love factoring. It'll get you through. All right, do example, or I will do example 3. So here we go. I've got 16y to the 5th minus 4y to the 4th plus 8y squared. My purpose in this problem is now we have both coefficient and variables that we're going to take out at the same time. So here goes. Let's just think of this one bit at a time. Between 16, 4, and 8, what's the greatest common factor? 4. Indeed it is, 4. And then how many y's can I factor out of each of those? Squared, you can factor 2, the smallest power. So there's 5 y's with the first one, 4 y's with the second, 2 y's with the last. So you can always take the smallest amount. If you were thinking y to the 5th, well, I can't take 5 y's out of this last term. It's only got 2 to give. Okay, so you're asking for more than it has. All right, so here goes. 16y to the 5th, I factored out the 4y squared. What's left from the first term? 4y to the third, beautiful. And then minus 4y to the fourth, I factored out 4y squared. What's left? Yep, indeed, y squared. And then finally, last but not least, 8y squared. I factor out the 4y squared, and I'm left with just what? Plus 2. Anybody having an issue? Am I going too fast? In my last class, somebody told me I was going too fast. They never said a thing until the end. So I just tell you, if I am, let me know. Okay, I'm just excited. I love teaching math. Okay. All right, well then, if you are as excited as I am, which I know you are, otherwise you wouldn't be here today, do exercise 6. All right, so this problem has m's and n's instead of a coefficient in a variable. So again, we're just going to think of one thing at a time. So as far as my m's are concerned, how many m's can I factor out of these? 2. It's always the smallest power. My choice is m squared or m to the 6th. So I take out the m to the 2nd. All right, how many n's can I factor out of both of these? 3, sure. N to the 3rd, fantastic. Always the smallest power. If you didn't quite get this, that's okay. You're gonna get your chance to make up for it in just a minute. So now I'm factoring out 2 m's and 3 n's. So my first term started out m squared n to the 4th, and I factored out m squared n to the 3rd. What's left? Just 1 n, yes. And we started out with 4 n's. We factored out 3 of them, and so I have 1 left. Started out with 2 m's. I factored both of those m's out, so there's no more m's left in that first term. Plus, all right, the second term is m to the 6th, n to the 3rd. I factored out m squared n to the 3rd. What's left from each of my factors? Okay, m to the 4th. Started out with 6 m's, factored out 2 of them. That leaves me 4. Great. Started out with 3 n's. Factored out 3 n's, leaves me no more n's. Question about that one? I wasn't getting as much feedback from you as the other ones. All right, we'll keep going. Do the next one, please. Exercise 7. All right, so I've got coefficients and I've got variables here. Let's look at the coefficients first. 24, 9, and 6. What is the greatest common factor? 3. And then, yes, I've got p squared, p to the 3rd, p to the 4th. What is the common factor of p? Yeah, you always take the lowest power, p squared. Fantastic. All right, now it's just division or seeing what's left over. So started out with 24p squared, factored out 3p squared. What's left? 24 divided by 3 is 8. P squared, I took out p squared. There's no more p's left in that first term. Minus 9p to the third, and I factored out 3p squared. What's left for the second term? 3p, great. In case you struggled on that, 9 divided by 3 leaves 3. I started with 3p's. I factored 2 of them out, so I have 1 left over. Plus, what's left for my last term? 2p squared. Indeed, that's true. 6 divided by 3 is 2. Started with 4p's, factored 2 of them out, left with 2. Still good? All right, next problem, exercise 8. Get another opportunity to factor out multiple variables. All righty, my 3 terms, the coefficients are 9, 3, 6. What's the greatest common factor? 3, yes. How many x's can they each give to me? X squared. How many y's can they each give to me? Always the lowest power you see. That is true. Now when I go through, 9 divided by 3 leaves 3. Started with 3 x's, took 2 out, so I have 1. Started with 2 y's, took 2 out, so no more y's on that first term. Then minus 3 divided by 3 is 1. Started with 2 x's, factored out 2 x's, so no more x's. Started with 2 y's, factored out 2 y's, so no more y's. So make sure you put that 1 there because that's all that's left over on that middle term. Plus 6 divided by 3 is 2. Started with 2 x's, factored out 2 x's, no more x's. Started out with 3 y's, factored out 2 y's, so I'm left with 1. We've got one more problem like this, and then we're going to start moving in a different direction. So exercise 9, factor out the common factor, please, the greatest common factor. So firstly, 25, 15, and 20, what's the greatest common factor among those 3 numbers? 5, that is true. And then how many A's can they each donate to me? A to the 4th, yes. And then how many B's? Excellent, B to the 3rd. Anybody having problems identifying that? If you can do that, you've got no problems doing this. But I understand that that can be a little bit of a struggle, especially if you haven't seen this in a while or at all. Okay, so now what's left over when I undistribute? Well, 25 divided by 5 leaves 5. 4 A's, I took out 4 A's, no more A's. 3 B's, took out 3 B's, no more B's. So the first term is just plain old simple 5. Plus 15 divided by 5 is 3. 5 A's, took 4 of them out, so I'm left with 1. 6 B's, took 3 of them out, I'm left with 3. So the middle term is 3AB to the third minus 20 divided by 5 leaves me 4. And then 4 A's, I took out 4 A's, so no more A's. B to the 6th, I took out 3 of them, I'm left with B to the third. Okay, so that's factoring out the greatest common factor. If you're following along, you're doing excellent work. You're sitting in good shape. I'm going to put several problems like that on the next test, so hopefully you're rooting for that. Before we turn the page and we go to the factoring by grouping, which is the other thing the title told us we we're going to be talking about today, I just wanted these last couple of examples to point out that we're going to be factoring other things, things with 3 terms called trinomials, and it's handy when the leading term, the coefficient in front of this leading term is positive. So if you see something that's negative in front of the leading term, meaning that that first term that has the highest power, then what you're going to do is you're going to factor out that negative, and it makes life a little easier when you have to factor what's left, which we're not going to do right here. So the only thing in common to all of these, there's no other number, just the negative. So I'm going to factor out that negative. And now a negative x squared divided by a negative divided by a negative gives me a positive every time. So positive x squared, great. Positive 5x divided by a negative leaves me negative, fantastic, negative 5x. And then negative 14 divided by negative, a negative divided by negative again is positive 14. Now I'm seeing in this example that if you're familiar with factoring trinomials, you can go a little further with that, but that's just an accident. We don't need to go any further because we haven't talked about it yet. Okay, but if you did it, bonus points for you. Great job. Okay, so go ahead and do exercise 10 and go ahead and do exercise 10 and 11. Let's just knock both those out. All right, so exercise 10 is just a replica of the previous problem. The leading term here is negative. So I want to, for issues that we'll talk about when we come back next week, I want to make sure that leading term is positive. It makes thinking through the rest of the factoring a little bit easier when that's possible. So when I factor the negative out of this one, I have a positive first term now, so positive y squared. I have a positive second term, so positive second 7x, and then I have a negative 25 right there. You'll notice on the last problem on this page, in addition to the negative, there was also a common factor. If you didn't notice that, that's okay. These things can occur in tandem, and that was my purpose to this problem. So in addition to the negative leading term, I'm going to factor out that 2 that is in common to all the terms. So I'm going to factor out a negative 2. Again, this one I believe turns out to be factorable further. That was not my intent. I just picked bad numbers coincidentally, so we're not going to take this any further. So when I factor out the negative 2, I have just x squared. Then I have 4 divided by negative 2 is negative 2x. And then 16 divided by negative 2 is negative 8. And there we go. I'm going to flip the page. We're going to continue on. My next example. So what this is a intermediate step, okay, just to get us used to doing a little observation for when we do what's called factoring by grouping. So notice on this problem, the way it's set up, this first problem, I still have 2 terms. Okay, terms are things that are multiplied together. So this right here, the x minus 5 times x plus 6, That's term 1. And then the x minus 5 times the 2x plus 5, that's term 2. Okay, so I know it looks like there's a lot more going on, but the bottom line is there's just 2 terms, and I've bracketed them for you. So of those 2 terms that I've bracketed, do you notice anything that they have in common? They both have, okay, I'm going to combine what both people said. They have an x minus 5 in common. Notice there's an x minus 5 right here, and there's an x minus 5 right there. So I'm going to practice factoring out the common factor like we were just doing. That x minus 5 that I underlined is the common factor. So I'm going to take it out, x minus 5. Now I'm going to caution you. Here's the most common mistake among students, and I do not want any of you to make it. Notice each of these just has one x minus 5. So that's why I factored out x minus 5, just one of them. Sometimes those students like to think, and I understand why, you're looking at this and you say, oh, there's an x minus 5 here and an x minus 5 there. So there's 2 of them, and you put a little power of 2 on that. That's wrong. We're not factoring out 2. We're factoring 1 from each. Okay, just like on the previous page when we factored x's and y's and p's and all the fun letters that we dealt with. So don't be persuaded. There's only one x minus 5 here, 1 there. Now, what's left over? When I factor out the x minus 5 from this first term, what's the factor left over? Yeah, that x plus 6, that's staring you right in the face. The x plus 6 is the thing that's left over. Then I've got this plus sign. I'm going to draw a little arrow. I'm trying not to make too big of a mess of this problem, but I want to make sure you know where everything's going. I bring down that plus sign, just like we did on the previous page. So I'm doing nothing different than I did on the previous page. It just looks a little different because the factors are binomials now instead of just monomials. In my second term, what's left over when I factor out the x minus 5? The 2x plus 5. Now notice on this, when I look at that factor that has the stuff left over, I have some like terms. So I've got x minus 5, that doesn't change. Then in the parentheses, x plus 2x is 3x, 6 plus 5 is 11. And there we go, that's what I have. All right, so I would like you to try the same thing. Exercise 12 is almost identical, just I changed the numbers a little bit. So give it a try, see how you do. All right, so again, I've got 2 terms here. I've got this first term, I've got this second term. Okay, what's in common? What is the factor you see in those 2 terms that's identical? That is true, the 3x minus 2. Okay, it's right here, it's right there. All right, when I factor out the 3x minus 2, what is left in the first term? Then I'm going to bring down that plus sign that's right in the middle, so plus. And then what's left from the second term? Yes, lots of voices. Y'all are excited to leave, I understand. And so there we go. So the 3x minus 2, nothing changes with that. Again, there's just one of them because each of the 2 terms only had 1 to give. And then in the parentheses, x plus 2x is 3x. 1 minus 5 is negative 4. And there's my completed problem. The next one, exercise 13, very similar. So why don't you go ahead one more time, factor out the common factor, and then we will talk about factoring by grouping, which what we're doing right now is just a step or a part of. Again, on this problem, I have two terms. I've got this first term right there, the z squared and the m plus n. Then I have a second term, 10 and the n plus n. So for those two terms, what do they share? What's in common? That's true, m plus n, great job. From the first term, when I factor out that m plus n, what's left over? Yep, there's two of those z's, z squared. There's a minus sign between these two terms, so I'm going to put a minus sign right there. And the second term, what's left over when I factor out the m plus n? 10. There you go. Nothing else to do. There's no like terms, so we are done with that problem. All right, so at long last, we're here to factoring by grouping. Okay, so example 6. Now, you might be saying, okay, Perkster, this is going to be fantastic. I've been excited about this all class, but how do I know when it's time to factor by grouping? That is a great question. Example 6, you notice, how many terms do I have on example 6? 4. There's 4 things, there's 4 pairs of things being multiplied together. So you know to factor by grouping when you have 4 terms. Okay, that's going to be your signal. Now, there are other ways to factor things by 4 terms, but I'm not interested in those in this class. So if I give you something with 4 terms, if it can be factored, it'll be by grouping. Okay, so there's no tricks or gimmicks here. So here's what you do. First, let's look at this. Is there anything in common, any one thing that is in common to all 4 terms? No. So there's no common factor. Just as an aside, if there was a common factor, you would factor it out. But I don't want to give up on this problem yet. And so here is the key. Okay, what we're going to do is instead of looking at all 4 terms all at once, we're going to group. Okay, we're going to group the first 2 together, and we're going to group the second 2 together. This is the grouping step. Okay, I'm just going to write a little note. Again, I'm not intentionally trying to make a big mess of the problem. But I just want to try to be clear for your notes. So that's the grouping step right there. I'm going to consider the first 2 terms by themselves and the last 2 terms by themselves. So now looking at the first 2 terms, is there anything in common to both of these? The A. Yeah, this is just like what we did on the front page, but we're just doing it a couple times now. So there's the A in common. So when I have AX and I take out the A, I've got X left over. When I've got negative AY and I take out the A, I've got negative Y left over. I'm going to put a plus between my 2 things. Don't ask me about that just yet. I'll tell you when it's not going to be a plus. Okay, so we'll address that in a couple problems, one thing at a time. Now, the second pair of terms, do they have anything in common? That is true, the B. And so BX, when I factor out the B, I have X left over, and then negative BY, when I factor out the B, I have negative Y left over. There it is. And now what I have, if you'll notice, is exactly what we had in the previous problems. I've grouped, now I have 2 terms. So I've got this first term, the A times the X minus Y. I've got this second term, the B times the X minus Y. Is there anything that those 2 terms share in common? X minus Y. That is it, X minus Y. They just have 1, so I'm just going to write down 1. What's left from the first term when I factor out the X minus Y? The A plus, what's left from the second term? B. There you go. Now remember, you can always check your factoring. That's the beautiful thing about this next test you're going to take, is when you factor something, you can just remultiply it to see if you got the right thing. So just do some foiling, first outers, inners, lasts, and you will get the 4 terms that we started with. All right, exercise 14, you get to practice the factoring by grouping. It's almost the exact same problem, just change the numbers and the letters a little bit. All right, once again, there's nothing in common to all 4 terms. So here's the grouping step. This is the key. Instead of thinking about all 4 terms all at once, I'm going to think about the first 2 terms, and then I'm going to think about the last 2 terms. That's the grouping step right there. That's why I drew those braces underneath each pair of terms. I've grouped them together. Now, out of the first group, the first 2, what's in common to those first 2? Okay, 3. 3m, when I factor out the 3, leaves me m. Negative 3n, when I factor out the 3, leaves me negative n. Again, I'm going to write down a plus. I will tell you what to look for when it's not going to be a plus. And what's left from the last 2 terms? What do they have in common? X. And when I factor out the x, xm divided by x leaves me m. Negative xn divided by x leaves me negative n. Did my grouping work? Do I have the same thing in the parentheses? That's how you know. If you don't have the exact same thing in the parentheses, the grouping did not work. And I'll just be forthright with you on the test. Everything will factor. Okay, there's nothing you're going to write down not factorable. Okay, I'm trying to see if I can teach you to factor. Okay, so if you get on the test, if you get something different in the parentheses, then go back to the drawing board and try again. Okay, so m minus n is now in common, so I'm going to factor that out. That's the second step. And then what's left from the first term is 3. What's left from the second term is x. So I get m minus n times 3 plus x. Those 2 binomials, if I FOIL them back together, I get what I started with. All right, one more, and then we'll talk about how I know if this is a plus or a minus here. I haven't addressed that just yet. But exercise 15, same thing again. All right, so once again, I've got 4 terms. That is my light bulb moment that this is probably going to be a grouping problem. So nothing is in common to all 4 terms all at once. So I'm going to group the first 2 and I'm going to group the last 2. What did you take out of the first 2 terms? 2x. Okay, a 2 and an x. That's great. So 2ax, when I take out Okay, let's continue. So you took out the 2x, so 2ax, I take out the 2 and the x, that leaves me a. The 4bx, 4 divided by 2 leaves me 2. I had bx, I took out the x, that leaves me b. Again, plus, we'll talk about that in about 30 seconds. What did you take out of the second pair of terms? A 3 and a y, fantastic. So 3ay, when I take out the 3y, we got a plus 6by, 6 divided by 3 is 2, and then by divided by y leaves b. Did the grouping work? Yeah. How do I know the grouping worked? You got the same exact thing in parentheses, so just factor that out now, a plus 2b. Again, there's only one of them. Each of my two terms has one of those to give me. And then from the first term, I have 2x plus 3y. There we go. Again, you can FOIL that. You'll get what we started with. All right, example 7. This is my last example for the day. And then I get to just watch you do a few problems before we go. So this one, I'm going to address the issue of how do I know if that sign between my two terms is a positive or a negative. So again, there's nothing in common to all four terms. So I'm going to do a little grouping here. So from the first pair of terms, I could take out a 3. This is very similar to a problem we've already done. Okay, just trying to keep things as simple as I can. So 3x divided by 3 leaves x. Negative 3y divided by 3 leaves negative y. Now here's the thing: you can, as you get better at this, as you do more problems, you'll be able to see this in advance. But here's what I'm thinking, because I've done a billion of these. I'm looking at this and I say, oh, I've got a positive x and a negative y. My next pair of terms is a negative x and a positive y. That's what tells me that I'm going to have to factor out a negative. I have my signs are opposite. Okay. Now, if you'll indulge me, I'm just going to pretend I don't notice that. So don't write this next bit down. That's why I'm going to do it in pencil so I can erase. I'm just going to pretend I didn't notice that. And so I'm going to put a plus because that's, I'm not used to writing in pencil, so I just broke it. I'm going to put a plus just because that's what we've been doing. And then I notice, hang on. Then I notice they have an A in common. So I'm going to take out an A. And so then I have negative ax, I've taken out the a, I have negative x. Ay, I've taken out the a, I have plus y. As it stands, did the grouping work? No. Why did the grouping not work? Well said. They're not exactly the same. And in fact, the difference is the second parentheses is opposite. Does everyone see that? Because that's your clue as you're learning how to do this. That's when the sign between them is going to be a negative, is when you have the exact opposite signs. Okay, so now I'm going to erase because erasing's fun. Yay. I'm a very good eraser. Look at that. You can barely see what was there. All right, so now what I'm going to do is, because of all that, I'm going to take out a negative, and then still we have that a in common. So a negative ax, when I factor out the negative a negative divided by a negative is a positive x. And then a positive ay, when I factor out the negative a positive divided by a negative leaves me a negative y. And now I have the exact same thing in the parentheses. The grouping worked. I can rejoice. X minus y is what they have in common. And then the first term has a 3. The second term has a minus a. And there's my fully factored expression. All right, well, try exercise 16. All right, so let's look at this problem that you've been gnawing on for a minute or two here and ask any questions. I know this can be a difficult thing and I don't want you to leave here any more frustrated with me than you have to be. So here we go. We're going to group these because there's nothing in common to all four terms all at the same time. And so out of the first two terms, I'm hoping that you factored out an A. An AB, when I factor out the A, leaves me B. And then negative 7A, when I factor out the A, leaves negative 7. All right, now the last two terms right here, what do we notice about the signs? They're opposite. The B term is negative where the B term was positive before. The plain old number is positive where the plain old number was negative. So that is my clue that I need to factor out a negative. And a negative, we've got 5 and 35, so a negative 5. So negative 5b, when I factor out a negative 5, leaves me b. 35 divided by negative 5 leaves me negative 7. The grouping worked because I've got the same exact thing in parentheses, so I will factor that thing out. And then what's left is an a from the first term and then a minus 5 from the second term. All right, exercise 17. I made a mistake, which you're used to by now, so I understand that. This should be 6ax plus 12bx. There should be an x right there, plus a plus 2b. So give that a try, factor by grouping. Now it will work. All right, so now that we've got that x in there, I'm going to group the first two terms. I'm going to group the last two terms. And out of the first two terms, 6ax plus 12bx, what's in common to those two terms? 6 and an x. Fantastic. So when I start off with 6ax and I factor out the 6x, I have a left over. 12 divided by 6 is 2. And when I start out with bx and factor out the x, I have a b. So 2b is that second term. Okay, the signs are all the same here, so that's not going to be a big deal. Is there anything in common to this last pair of terms, the a plus 2b? Well, what do we notice about the a plus 2b? Is there anything interesting about it? It matches the parentheses. Yeah, so I'm just going to throw some parentheses around that, okay? Because now I have the same thing in my two groupings. So a plus 2b and a plus 2b, I can factor out the a plus 2b. That's great. What's left from the first term is 6x. Now, this is a flashback to something that I intentionally did on the front page. When I factor out the a plus 2b from this second term, what's left there? A 1. So plus 1, yes. Okay, we encountered a situation like that on the front page. All right, final couple problems. You're doing good. I appreciate your endurance with me today. Do exercise 18. On this particular problem, okay, first two terms, last two terms. What do the first two terms, what can I factor out of those? Yep, smallest power, just like we talked about before, just bringing that back to our short-term memory. M to the third, when I factor two m's out, I'm left with 1m. 4m squared, when I factor two m's out, I have plus 4. Now the second two terms, in addition to the 6, what else do I have to factor out? Yeah, the negative, because the signs are all different. Okay, so both of these signs are negative. Both of the things I have in parentheses are positive. So I'm going to factor out a negative as well as that 6 that they have in common. So a negative 6 divided by a negative 6 is a positive m. A negative 24 divided by a negative 6 is a positive 4. The grouping worked. I'm super happy about that. Otherwise, I made another typo, which I wouldn't be happy about. So the m plus 4 is in common, and then m squared minus 6 is what's left over. All right, exercise 19. Before I leave you to do that on your own, I want to mention why this problem's on here. So let's group this together. I'm going to do the first bit and then give you a piece of advice. When I group this, what's in common to the first two terms? Nothing. What's in common to the last two terms? Okay, that's unfortunate, because then that means there's nothing in common. So before I give up on this problem, though, sometimes with grouping, the order does matter. So here's what I advise you to do. If you come across a problem on your homework, now again, everything on the test will be factorable. Okay, I might ask you to change the order here like I'm about to do, but everything will be factorable. On your homework, before you give up, change the order of the factors. What I like to do is I just like to take the constant term and I just like to throw it at the end. It's kind of the easiest thing to do. So I'm going to rewrite this problem as p squared q squared minus 2q squared plus 5p squared minus 10. And now you'll notice the grouping will work. Okay, so don't give up on a problem if at first it looks like you're not going to have things in common. All right, once you change the order, it's a pretty straightforward grouping problem. So I'm going to group the first two. I'm going to group the last two. Out of the first two, notice I can take a q squared. They both have that same factor right there. And p squared, q squared, when I factor out the q squared, leaves p squared. Minus 2q squared, when I take out the q squared, leaves minus 2. The second pair of terms, I could just take out a 5. The signs are going to be just fine, so I don't need to take out a negative 5. 5p squared divided by 5 leaves p squared. And then negative 10 divided by 5 leaves negative 2. The grouping worked. I've got a p squared minus 2 in both parentheses, so I factor that out. And then I have a q squared left from the first term and a plus 5 left from the second term. And that's my fully factored expression. Last problem for the day. There's not really much different in this than some of the other problems. The reason I put this one on here is just because of the coefficients, just making sure that, that you notice that all 4 terms have something in common. So what I would do first, if I were you, is factor out the common factor to all 4 terms. And then group. And this should say exercise 20. There we go. Now the worksheet's perfect. All right, so just for time's sake, because I know I've got a test to give back to you, first thing I notice is I can take a 4 out of every term. So I'm going to do that first. Always want to work with the smallest possible numbers. So 12 divided by 4 leaves 3wy. Negative 24 divided by 4 leaves me negative 6xy. 4wz divided by 4 leaves me wz. And then negative 8xz divided by 4 leaves me negative 2xz. Now that I've factored the 4 out, the 4 is part of my final answer. I'm just going to draw a little arrow to remind me of that. We'll bring the 4 back in. That's going to be my lead. But now I've got to do grouping on the stuff that's inside here. So I will do that. So out of the first 2 terms in the parentheses, I can take a 3 and a y. And when I do that, 3wy, factor out the 3y of w. Minus 6xy, when I factor out the 3y, leaves me negative 2x. The second pair of terms, I can take out a z. wz, factor out the z, leaves me w. My signs are going to be just fine, so I don't need to take a negative or anything. And then negative 2xz, factor out the z, is negative 2x. The grouping worked. I've got the same thing in both sets of parentheses, so I'll factor it out. So the next thing is w minus 2x. And then from the first term, I have a 3y. From the second term, a plus z. So when there's something in common to all the terms, take that out. Practice factoring that greatest common factor out. Then you can group if that is what the problem is asking for.